Hi. Hi everyone. Today we are going to see a process diagram. It's not actually a process diagram. It's actually a flow chart. So we are going to see the amount of energy lost from the generation of electricity to the time it reaches the consumer from black and brown coal. So from black and brown coal, the energy generation is initiated and it reaches the customer. From this point to this point, how much energy is lost? Out of the total energy loss, that is 100%, 73% is lost at the power station, 3% is lost when it is transmitted and distributed, 24% is lost when it reaches the consumer. So, or when it is supplied to the consumer. The same thing here. Brown coal, 63% is lost at the power station, 3% is lost when it is transmitted and distributed, and 34% is lost when it reaches the customer. When it supplies to the customer, means that the customer, the end user, that is the final user, with the supplier, 34% is lost. So the two sources of energy, can see the maximum energy is lost at the power station. The minimum is lost in transmission and distribution. And for the consumer, it's 24 and 34. So it's not a complex task. Let's see how we can manage it. We need to frame an introduction here. An account of the share of energy lost from black and brown coal from the generation to its supply is depicted in the given charts. So what is depicted in the given charts? An account is depicted in the given charts. What the account? The account is the share of energy lost. From which point to which point? From this point to this point. Complete. So all the questions are answered. So there is no question further. So I have answered all the questions. Where is it distributed? I don't know. The data is not given. When is it distributed? I don't know, because they have not said it was in this particular period, or this particular, not in the past, not in the present, not in the future. Naturally, it becomes present tense. So we can say it's in the present tense because I don't have a time frame. It's a process diagram. So this is a process starting from the generation of electricity, from the generation to the supply to the end user, the consumer, whoever it is, maybe the household user or the industrial user, whoever it is. So the first task is complete for us. It's concise, it's formal, and I have not copy pasted the prompt from the question. Now we look at the overview. It's clear that the overall proportion of lost energy at various stages is almost similar in both cases, despite minor variations. It is clear. It is obvious. It is tangible that the overall proportion of lost energy at various stages, this stage, and this stage, is almost similar. We have a 10%, we don't have a 10% difference here and here, and we don't have any difference here. So despite minor variations, it's not a major variation. 10% variation is not a major variation. Despite minor variation, it's almost this, the data is almost similar. Now that the major proportion of energy is lost from the power station, and the proportion of energy lost from the stage of transmission and distribution is just 3%. It is exactly the same. And when it comes to the consumer, it is 24 and 34, 10% difference there. Despite minor variations are there, the overall proportion of lost energy at various stages is almost similar in both the cases of black coal and brown coal. I think that area is also clear. Now, when I look at the next area, as per the charts, you can see the charts. It's clear, yes, it's clear that most energy loss occurs. It's used in the present tense because it is a process diagram. So it happens. The energy generates, the energy is generated and it is supplied. It is transmitted and supplied. It reaches the end customer. It's clear that most energy loss occurs at the power station when the power generation occurs. Yes, when the power generation occurs, it's not said in this thing, so we can say it is not an assumption. When the power generation occurs only, the power station is functioning. So it is not a data from outside. It's not an assumption. It is clear from the picture that the energy is produced, that the power generation is initiated, then only power station will be functioning. It's clear. Even the word power generation is not given in the picture. It is not an assumption, it is a proof. It's very clear that the power generation occurs, then only this thing function. Yes. When 73% of the total loss occurs in case of black hole at this stage, yes, at black hole, 73% of the energy is lost at this stage. In case of brown coal, it is 10% less. 73 minus 10, it is 63. So why I have not told it is 73 and 63? Because I need to make a comparison. So you might have asked me a question. What if I finish this thing? And what if I finish this thing later? I complete this process number 1, then I complete this process number 1. That is a poor comparison. That is a very bad comparison. I don't recommend that comparison. If you wish, you can do that. You can do that. No issues at all. But when you do that, your word count will be increasing. You need to repeat what you have said before. So I don't recommend that case. I recommend a case like this. When it reaches the power station, this is the energy loss here. And when this reaches the power station, this is the percentage of energy loss. And I already said this is 73%. Then I can say it is 10%. If I already said this is 63%, then I can say this is 10% more. So the comparison is very clear. So I am not going with this way. I am going with this way, like this, like this, like this. Both the ways. It's going here, stuck there, coming here. It's going there, stuck there, coming here. Going there, stuck there, coming here. This is a better comparison. Instead of presentation, you just present this thing, present this thing. Comparison is less. So I don't recommend this style. I recommend this style. It should go like this, should compare like this. It should go like this, compare like this. Go like this, compare like this. This is a better way of comparison. So if you present this thing in a better way, then you can fetch more marks there. And if you just want an average score, you can go ahead with this thing. This is also a comparison there. This is also a comparison. But I call it a presentation, not really a comparison. Okay, anyway, we come to the second paragraph. It's very simple. The proportional difference of energy loss from the transmission and distribution of energy from both the resources is 0. How can I say that it's 0? The proportional difference. This is the proportional difference. The proportional difference of energy loss from the transmission and distribution of energy from both the sources, from this source and from this source, is 0 because it is 3. 3 minus 3 is 0. So the difference is 0. Here 73 minus 63, it is 10. So the difference is 10. Here 34 minus 24, it is 10. So the difference is 10. So here it is 10, here it is 10. The proportional difference here is 0. You must have understood that. In both the cases, the share of energy lost is just 3%. Then I have to say, in both the cases, it is just 3%. My matter is clear there. Let's go ahead. The last paragraph. However, it's not the case here. However, I have used the word however. A greater proportion of energy loss occurs with the supply of energy to the final customer, with the supply of energy to the final consumer. Increase of brown coal. And this is 34% of the total. Of the total means of the total loss of energy, it is 34%, which is 10% more than the supply of energy from black hole. It means this is 10% more. What is 10% more? This is 10% more. That's it. So overall, if you see how is the grouping of the paragraphs. In the introduction, I have said What is the picture? And what is it about? In the overview, I have said what is the summary of the picture. The first paragraph I've said about the first stage, that's what's happening in the power station, where the most energy is lost. The second paragraph I've said transmission and distribution, where there is no change. The third paragraph I've said when it reaches the consumer. I don't have a specific idea. Let's move on to the picture once again and see. I don't have a specific idea how this 24 or 34% is lost when the consumer is using this thing or when it is supplied to this thing. I can say that when it reaches the final customer, when it reaches the ultimate consumer, when it is supplied to the final consumer, I can say the energy is lost. I don't know whether when it is supplied or when the consumer uses it, 24% is lost. It's not very clear here. So in that case, I need to say when it reaches the end consumer, 24% is lost, 34% is lost. So that is a picture that I think that the picture is very clear here, and the explanation is very clear here. Thank you.